want to welcome you to my lecture today. Of course, today we the way I'm going to handle this today because we got materials for yesterday and today. So I'm actually going to use board. Maybe 95% of what we're going to do today will be on the board, and it's going to be more theoretical because I'm going to do some derivations. And all that we advise you to do is to focus more on the board and you ask questions where necessary. Okay, so we started discrete probability distributions, and today I'm actually going to walk you through each of these probability distribution. I'm going to start from Bernoulli. Then I'm going to go to binomial, geometric, discrete, uniform, and negative binomial distributions. So I need you to be focused, and we're starting right now. I believe you can all hear me, right? Okay. Now I'm going to start with Bernoulli distribution. So Bernoulli distribution is one of the discrete probability distribution. For instance, if X follow Bernoulli with parameter 1 and P. Okay, the parameter, the one here is actually talking about the numbers of triad. We use Bernoulli distribution to model, a random variable with two possible outcomes. So the probability mass function is the p of x equal to this equal p raised to power x 1 minus p raised to power that. Now, let me tell you this. Every discrete probability distribution have what I call probability mass function. Okay? So the probability mass function of a Bernoulli distribution is given as this. Okay? P is the probability of success. X is the number of success. We can also call S the number of characteristics of interest. And of course, the state space is going to be 0, 1. Now, the very first thing I'm going to show is what is the expected value of X? What is the variance of X? Okay, I want to show this. Every probability distribution has expectation of X, the variance of X. So what I want to do right now, I want to derive this, okay, from this. Okay, now if I want to derive that, the expected value of X for discrete probability distribution has this formula. Now, every discrete probability distribution has this formula if I want to find expected value of X. Okay, I'm actually going to use this for Bernoulli, for binomial, for geometric, for every discrete probability distribution. But the only difference is going to be this guy. Okay, now this guy now, I'm actually going to use the probability mass function of Bernoulli distribution. So right now, I'm going to do X start from 0 to 1, X. Then this guy is P raised to power X 1 minus P, that. Okay? Now, let's take a look at this guy now. Okay? Now, when X equal to 0, so when X equal to 0, P raised to power 0, 1 minus P raised to power 1 minus 0 plus 1, P raised to power 1, 1 minus P raised to power 1 minus 1. Now we take a look at this because of the 0 here, right? When you take a look at this, then expected value of S equal to P. So that is how to show that if X follow a Bernoulli probability distribution, the expected value of S equal to P. Is there anyone who doesn't understand how I derive that to be that? Is there anyone doesn't understand that? Okay, now let's go to variance. Now, the variance of S is expected value of S squared minus expected value of S all squared. Now, whether discrete or continuous, of course, we're going to start continuous distribution next week. So whether discrete or continuous distribution, if I want to find the variance of X, the variance of S is this. Okay, now I've gotten expected value of X, which is this. Then I want to find expected value of S squared. Okay, now if I want to find expected value of S squared for discrete random variable, I'm actually going to have S squared this. Okay, I need you to take a look at this guy. Expected value of S for discrete random variable, I'm going to have that. Okay, now S squared, I'm going to square this. Now, because of the fact that Bernoulli is involved, I'm actually going to write S star from 0 to 1. Okay, then I'm going to write S star from 0 to 1, S squared, P raised to power X, 1 minus P, this. Okay, so what I'm going to do right now, 0 squared, P raised to power that, 1 minus this, 1 minus 0, plus 1 squared, P raised to power 1, 1 minus P, raised to power that. Okay, this guy, that's going to be 0, right? And this is also going to be P. Okay, now expected value of S squared equal to P. Okay, now if I come here now, the variance of S is going to be expected value of S squared, so P minus expected value of S all squared. You know, we got this one, so that's going to be P squared. And what do I have? Is there any question? Now, what I've shown you now is how to derive the mean and variance of a random variable S that follow Bernoulli distribution. Is there any question? I also allow you to take a picture. So if you want to take a picture, there's no problem. If you want to take a picture, there's no problem at all. Okay, so this is that. This distribution, okay, we apply this distribution to a random variable that has two possible outcomes. Okay, and you only try how many times? Once. Okay, so this is the average, and this is the variance. If this is the variance, then the standard deviation of S is the square root of the variance, so it's going to be that. Okay? Now, the next thing I want to do now is I'm done with the Bernoulli. I want to go to binomial. I'm also going to derive the mean and variance. Okay? Before I go into binomial, is there any question? Any question?